For a half plus 2/3, we're going to add these fractions. Adding's okay, but they're not in a very good form for adding right now, are they? Why not? Anyone? Yeah, true.
The denominators are not the same.
Yeah, very good. They're not talking the same language, are they? Okay, so therefore, and you can see what Maria's done. She's put them on the same denominator, being 6. Why is 6 a good number? Why is 6 good? So, Rinesh, yeah.
Because 2 times 3 is 6 and they're both the common multiple.
Yeah, very good. The word we're looking for is, the phrase rather, is lowest common multiple. You could do over 12 or over 24. Those would all work, but 6 is better because it's smaller. It's easier to deal with. So what's a half if you make the denominator 6? What do I write this as? What over what is equal to a half? Yeah, Nick? No, yeah? Jerome?
3/6.
3/6, very good. And 2/3, what do I do at the top bottom? Yeah, Maria? 4/6. There we go. Okay, so when you put these together, now they're talking the same language. Now I can just add the numerators, and you can see, leaving it in a mixed numeral, that's kind of nice and neat. Not required, but it's nice. What do we do to this thing to get x equals -3 out? There's one thing we need to do to both sides, yeah.
Take away 3.
Yeah, we want to take away a number. Oh, my colors are all here.
I'll take away 2.
I want to take away a number that leaves just the x by itself. And the number I heard was take away 5, take away 5. Yeah? The reason that's great is because it gets rid of all of this all in one hit, leaves you with that. Now this one, let's see what's going on here, okay? Because I can see what's happened. This is actually I would be very, very unsurprised if a lot of us have put that. It's a very easy mistake to make. Let me go through what I think maybe the thought process was, okay? There's a 1 here. I don't want that 1 to be there. So I'm going to take 1 away from both sides. I'm going to take 1 away from both sides. Now that it's not on the left, it leaves me with that. What's 7 take away 1? It's 6. So you can see where I get x equals 2 from, right? I divide both sides by 3. So what's gone wrong? What did I do that was problematic about the way I approached it? Anyone else who wants to offer? Anyone want to suggest? Brad, do you want to have a shot?
Like, it says like 3x minus 1 equals 7. So, like, the minus 1, like, goes on to like 3x.
Okay, so I'm subtracting 1 here.
Yeah.
But why is it a problem? I think you're right. But why can't I take away 1 from both sides? Because I want not to be there anymore, so why can't I remove it? Christian, what do you think?
If you take away 1 from both sides, it becomes 3x minus 2 equals 6.
Oh, very good. So because there's subtraction here, which is what you're saying, Brad, when you subtract 1 again, it becomes an even bigger subtraction. It'll be take away 2, right? So in fact, I don't want to, this is wrong. I don't want to subtract 1 from both sides. What should I actually do to both sides to get an answer? Anyone want to suggest? Yeah, Nikhil.
Add 1.
Very good. I want to do the opposite of whatever's there. Okay, so if I add 1 here and add 1 here, that will leave me with 3x. What's on the right hand side? 8. So therefore, what should I do now to get to my final line? Yeah, Jaron.
8 divided by 3.
Very good. That's an improper fraction. That's fine. If you wanted to change it into a mixed numeral, what would it be? 8 over 3.
Wait, I wrote decimals, 2.6666.
Okay, so you could write 2.66 on and on and on and on. That's fine, but you'd have to write a lot of 6s to go on forever, and you'd need an infinite number of them. It might be easier just to say that 8 is 6 plus 2, right? Yeah. So 6/3 is 2, and then there are 2/3 left over, and there's your mixed numeral. Okay. All right, last one. Force axes of symmetry is exactly right. Just in case you couldn't quite see them, if you drew a diagram, it was really easy to see. Diagrams are awesome. They don't have to be beautiful, but you know what they say, a picture says 1,000 words, right? The easiest axis of symmetry is there, right down the middle. You can see Christian's drawn one across. The ones that are trickiest are the diagonals, right? Here, all the way through. If you turn your head, can you turn your head with me 45 degrees to the left or right? You'll see either of them. And you can see, you can reflect across and get the same shape, right? By the way, that's something the square can do, but do you notice the rectangle can't do that? How many axes of symmetry does a rectangle have?
2.
It's only got 2, the first 2 that we mentioned, because look, if I tried, again, turn your head with me. Do you see you wouldn't get the shape? You wouldn't get it. When you reflect it across, for example, if I reflect it across this bit, I get a shape that looks more like this. Do you see that? Do you see the reflection? And it's the same the other way. So you don't get a symmetrical shape.